Dear students, welcome to our next lecture. Now, in previous lecture, we have done the topic parse tree. We have picked that what is parse tree, how to design any parse tree for context-free grammar, what is leftmost derivation tree, rightmost derivation tree, designing of all those stuff. So we have completed all those things in our last lecture. Now in today's lecture, we are going to focus on one specific thing, that is ambiguity in CFG. We are going to pick that what is ambiguous thing with respect to any grammar. Now, how to identify that whether any grammar is ambiguous. So before we'll move into that thing, let's first of all focus that what do we mean by ambiguous things. Now, what is actually ambiguous things? Now, let's take one example. Suppose in Hindi, I have one sentence which says, "Roko mat jane do." Now, this is one sentence, and if I do not write any specific mark in between, then it says simply "Roko mat jane do," which have two different meanings and both are totally contrast in nature. The first meaning says "Roko mat jane do," which says कि उसे रोको और मत जाने दो. But I can say or I can interpret in other way also, that is रोको मत जाने दो. It means उसे मत रोको, उसे जाने दो. So by one sentence I can have multiple meanings, and surprisingly both are totally contrast in nature. So these things are very complex, and that can confuse your machines if suppose rules are written in such a way that machine can interpret two different meanings, so which will be performed by that machine. Hence, once we are designing machine, we need to be sure that the grammar or rule which we are going to encode should have strict specific meaning. And that is the main point, that why we focus on these kind of things. So this is known as ambiguity. That once you are having multiple meaning of sentences, then that is known as ambiguity. In any specific rule, if you are having ambiguity, then that rule is known as ambiguous. So we are going to focus on context-free grammar, because we have done all those stuff with respect to context-free grammar, and we are going to focus that when any context-free grammar becomes ambiguous. Now, let's take one more example before we proceed for context-free grammar. So, suppose I have one example, that is, he ate the cookies on the floor. Now this is one simple sentence, but it can give me two different meanings. Now let's interpret this thing. First of all, if I can read in this manner, that he ate the cookies on the floor, or I can have he ate the cookies on the floor. Now both are having totally different meaning. Now the thing is, which meaning is right? So the answer is we don't know. Might be possible that both are right, but in any specific situation, there is a possibility that only one meaning is correct and other one is wrong. Hence, how to decide that what is the perspective? So, in terms of machine, it becomes hard to judge the perspective of the things and identify that which one is right. Hence, this is ambiguous. So, we have picked two basic examples, one from Hindi language, one from English language. So, whenever we want to design any language, we had picked that we require grammar. So, definitely there are certain loopholes in grammar. Because of that, we got two different meanings. So, once we are trying to write context-free grammar, can we identify that the grammar is ambiguous? And if we can identify, we can avoid that grammar. So let's try to pick one example and we'll try to identify that grammar is ambiguous or not. So I'm taking one example. Suppose I'm having example E produces E plus E, E star E, 1, 2, 3. Now, I want to prove that this grammar is ambiguous. For that, what I need to do, I need to take first of all certain string. Now, suppose I have taken one string, suppose that is 2 plus 3 into 2. Now, as per our rule, it says that what we are going to do first, that is 3 into 2, that will be 6, plus 2, 8. So the answer is 8. So let's try to design or derive this string from the given grammar. I am going to write rule number 1, 2, 3, 4, 5. So in this particular grammar, I have 5 production rules. E produces E plus E, E produces E star E, E produces 1, E produces 2, E produces 3. Now, because I am having only one variable, so I am going to straight away start from this one, and suppose I am going to design leftmost derivation tree. So let's try to derive this string which says E produces, now what I want, 2 plus 3 into 2. So I can have plus, so what I can do? I can do first of all by rule number 1, which is E plus E. Now before plus I require only 2, so logically what I should do, I should convert this into 2, then E star E, this says 3, 2, so from left to right reading it says 2 plus 3 star 2. Now if I want to generate RMD, what I'll do, E produces E plus E. I'm going to first of all solve the right variable first, as we have done in our previous class. E star E, then again write 1, 2, 3 and 2. So we got leftmost derivation tree and rightmost derivation tree, and we have generated 2 plus 3 star 2. 2 plus 3 star 2. Now the thing is, yes, we are able to generate tree. It means this particular string can be derived from this particular grammar. Now the